taking a minute, I'm going to share that with you right now. Now, I am going to show you some statistics. I know that what I'm about to show you makes absolutely no sense to you whatsoever. That is okay. But let me go ahead and share that with you, and I'll show you what I did. So I kind of told you the purpose of the study on Monday, the idea being that the more deeply that you process something, the better your memory for it is going to be. So for some words that I showed you, I asked you about case, what the words looked like. Were they uppercase or lowercase? For other words, I asked you if they rhymed with a certain word. That is kind of a medium level of processing. And then finally, I did a deep level of processing where I asked you kind of what the word meant. And so kind of based on that, this original study was developed by Craik and Lockhart in 1972. This is what is referred to as levels of processing theory. And given that we're starting memory today, it actually kind of makes a lot of sense that we would do that. But the idea being the more deeply you process something, the better your memory for it is going to be. So I went through all of your recognition tests. I counted up how many you got that were shallow, medium, and deep. And I know that this is not going to make sense to you. These are scary numbers. If you are becoming a psychology major, at some point you will understand what these numbers mean. But just trust me on this one. These are significant effects. We actually were able to replicate the finding. So I know that that's not really going to make a lot of sense to you. So here's a graph. So let me go ahead and put this in a 100% graph. So here's your performance. So I did proportion correct. So there were 20 words that you did that were shallow, 20 that were medium, and 20 that were deep. So I took the percentage that you got correct out of 20 for every single one of you. And here's kind of what we find. So here is the mean percentage correct. These are 95% confidence intervals. And as you can kind of see, there's a generally shallow processing performed the worst. Medium was in the middle, but you can see that medium wasn't all that different from shallow processing. For a lot of you, your medium and your shallow processing were about the same. But when we look at deep processing, look at how much better everybody's recognition performance was. Many of you got 18 out of 20. We actually got somebody who got 20 out of 20. Who got all 20 of the words deeply processed correct. So this kind of replicates our original finding that the more deeply you process something, the more that you try to think about something and potentially even tie it in with what you already know, the better your memory for that's going to be. Cool, you helped and you learned something. All right. So that's me kind of sharing the findings. So now we are going to finish up with the last two slides of learning and conditioning. And then I want you to get a scrap piece of paper out. We're going to do a memory test. Yay. Okay. Okay. So one of the things that I kind of mentioned with observational learning, and by the way, I think they superimposed this because I'm pretty sure that's an image from Breaking Bad on that TV. I'm pretty sure that's an image from Breaking Bad, but it's on like an old school TV VCR system. So I don't think this is necessarily correct. But what we tend to find is that whether it is on TV or through family members, oftentimes what we find is that especially when we're young and we don't have critical thinking skills, we have a tendency to imitate what we see. You watch a lot of Teenage Mutant Ninja Turtles growing up, you're going to go out and pretend to be a Ninja Turtle. And what do Ninja Turtles do? They fight and they kick and stuff. If you watch a lot of TV where people say phrases like shut up or things like that, you're going to find you put that more into your language. So generally what we are going to find is that antisocial models, things that hurt other people, either through insults, put downs, or physical violence, often tend to have antisocial effects. especially when you're young and you can't tell the difference between real and fantasy. It's part of the reason, like, it doesn't really happen that much anymore, but when I was growing up, there were a lot of people who were very, very concerned about cartoon violence, especially things like Teenage Mutant Ninja Turtles, things like Power Rangers. What's kind of interesting is that your alternative at the time was like Barney. I would much rather watch Power Rangers than watch Barney. Although in my defense, when both of those were out, I was like 11. So of course I'm going to watch Power Rangers, even if I'm a little too old for it. But here's the good thing. So it's kind of clear that if we have negative role models or we are watching negative media, this is going to have a negative effect on us if we're young and we don't have the critical thinking skills to go, I don't have to imitate everything I see. But what this means is that it cuts both ways. That if you have role models in your life or you are watching TV that has a lot of positive, helpful models, oftentimes we're going to find that those have positive effects. It's part of the reason why growing up, like even now, I appreciate shows like Mr. Rogers' Neighborhood and Sesame Street, because in addition to being educational, they often teach good lessons. So if you want to be, and that power of conformity, by the way, is really strong, even when you're an adult. I remember kind of at the very beginning of the pandemic, and I'm less removed from it now, but I remember at the very beginning of the pandemic, especially here in Nevada, I remember walking around wearing a mask when nobody else was, and I'm kind of like, am I the one that's wrong? Because even though I knew I felt that I was doing the right thing. If you're welcome to disagree, but I felt like I was doing a good thing for me, protecting myself and the people around me. But when you're surrounded by a lot of people who are doing something different, that urge to want to conform is really strong. Like, we're designed to exist in community, and going against the crowd, at least in our ancestral history, meant ostracism. And ostracism in our ancestral history meant death. Nobody wants that. So there's always going to be this need for us to want to conform. But at the same time, hopefully somebody like me was being a pro-social model, maybe for somebody else. I don't know. At this point, I'm like, I can only control me. I am not going to worry about what other people do. At the end of the day, I'm doing the things that feel good for me, and that's okay. And I'm not going to judge anybody else for doing anything different. Because it's just too exhausting to focus on what other people are doing at this point. It's just too much. Okay, so there is actually data to back up the findings. So oftentimes we will find that people who are violent or kids that are violent tend to watch more violent TV. But oftentimes what we find is that it's very correlational in nature. And the thing about correlation is that we never know what is the true cause. So it's possible violent people just like to watch more violent TV, or TV causes violence, or there's some other third variable that accounts for both that comes into play. It could be family structure. So maybe there's something going on in your family that makes you more violent and makes you more likely to watch more violent TV. But what we do find is there is a causal effect. Gentile and others back in 2004 actually did find that exposure to violent media does lead to an increase in expressed aggression in kids. Children mimic what they see because they are trying to learn. And that's true whether it's real violence or fantasy violence. They can't tell the difference between real and fantasy. just because I'm talking about this with kids doesn't mean that there's not some element of truth to this for you as well. How many of you have heard the idea that you're basically the average of the 5 people that you hang out with the most? So generally, if you surround yourself with people who build each other up, bring out the best in each other, and model pro-social behaviors, you're going to be more likely to do that too. All right, is everybody good? Okay, so we're going to move on to talking about memory. But before we do, I want to do a memory test. We're going to do a lot of these. Okay, so I'm going to go ahead and pull this up. But what I'd like you to do is get a scrap piece of paper out right now. Or you can write in your notes, either one. I'm going to give you a list of words. Do not write them down as I am speaking them. I want you to listen, and this is a memory test, not a listening test or a writing test. So once I tell you to recall all of the items, what I'd like you to do is remember all of the items in any order that you want, okay? So I'm going to read this list. It's about 16 words. Are you ready? Okay. Gotta find the good one. Where is it? It's my favorite. Okay. Soda, heart, tooth, tart, taste, sour, bitter, good, sugar, candy, nice, cake, pie, chocolate, honey. Go. Okay. Everybody good? Okay, so first things first, can I ask you a question? If you recall the word sweet, can you please raise your hand? Okay, I don't know how to tell you this. I just created a false memory for you because sweet was not on that list. Okay, so this is a really famous study that is by Deese, Roediger, and McDermott. It's called the Drm Paradigm. This was popularized by Roediger and McDermott in 1995. Basically, if I give you a lot of words that are related to a word that I never say, many of you will recall that word, even if I never actually presented it to you. Isn't that cool? It doesn't take much to create a false memory. Now, let's go ahead and take a look at the rest of the words. So, raise your hand if you recalled the following words from the list. Raise your hand if you recalled any of the following: soda, heart, tooth, or tart. Okay, those were the first few items in the list. Most of you tended to recall those. Raise your hand if you recalled pie, chocolate, or honey. Quite a few of you as well. Did anybody get good? Okay, a few. Less than the items at the beginning of the list or the end of the list. Did anybody get bitter? Okay, a few people. Anybody get sugar? Okay, once again, kind of in the middle. So here's what's kind of interesting. How many of you did really good at the beginning of the list and the end of the list, but then when you get to the middle, you kind of blank out? How many of you did something like this? And by the way, probably most of you. Did you repeat words to yourself as I started saying them? How many of you had this experience where you had too many words to remember at some point? So it's almost like you're juggling all of these different balls, and then you throw them up in the air and you go, that's it, I'm not going to do it anymore. I'm just going to listen. We all do that. So here's what's kind of interesting. Those first few words that you recall on the list, that's your long-term memory. You have time to repeat them to yourself and put them into your long-term memory. And at some point, that rehearsal, that repetition is going to be too much. So you just decide to listen. The last few items on the list are short-term memory. Those are what you were able to grab from the end of the list just by listening. So we actually use the fact that you recall the first items from the list and the last items from the list as evidence of both long-term memory and short-term memory. Pretty cool, huh? Okay, so with that in mind, I hope I have gotten you interested in memory. Now, how many of you would say you have a really good memory? How many of you would say you have a really bad memory? How many of you are kind of in the middle? Okay, now for those of you who say you have a really bad memory, I do want to offer you a little bit of encouragement. You made it here to this class, which requires memory. Some of you drove a car to get here, which requires memory. Some of you came to walk here, which requires memory of location. You remembered how to put your clothes on, which requires memory. You're able to write and remember the words that I'm saying because you remember aspects of your language. This requires memory. So the fact that you are here at all and writing down words with me shows that your memory is probably better than you think. And in general, we remember our failures more than we remember our successes. So just something to keep in mind. But folks, this is my favorite topic, and not just because I study it, but even before, I was always really interested. My memory has always been really good. I play trivia, and one of my favorite things about trivia is that I won't have the answer, and then all of a sudden, like magic, it just pops into my mind. How did it get there? I don't know. So I've been trying to figure it out. Now compare that with somebody like my doctoral advisor. He studies memory because his is so bad. He doesn't sometimes even remember his own birthday. I think one time he had to look up his Wikipedia page that had his birthday on it just so he remembered it. Like, he's just so brilliant that like trying to remember his birthday is beneath him. That sort of thing. Like, that's how brilliant he is. Like, he's absent-minded professor, but he's so smart. Okay, so this is one of my favorite topics now. We're probably not going to have time to cover everything, so I might send you a link to videos that I have already recorded about memory so that you can catch up, okay? But I'm going to try to cover as much as I can so you'll be ready on the test. As you're kind of writing this down, this is just an overview of what we're going to be talking about. Would you prefer a review session on Monday or Tuesday? You want Tuesday? Okay. Would you prefer that in person or on Zoom? Okay, we will do it on Tuesday on Zoom. We'll pick a time on Monday, okay? If you can't make it, somebody can record it for you. Okay, so we're going to talk about what memory is, why it's important, some of the general properties of memory, how memories are built, why we forget, which is normal and healthy. It is healthy to forget things. You don't need to remember what you had for breakfast every single day for the past 20 years. Memory construction, the fact that memories are not like photographs. And if we have time, your book does talk a little bit about how to improve your memory. Okay, do not write this down. This is just a quote that kind of explains why I find memory so interesting and so important. So this comes from a book, an autobiography by Eric Kandel. Eric Kandel has won the Nobel Prize for his work looking at long-term potentiation, which we'll talk about a little bit later. It is the cellular basis for all learning and memory. So when you learn something or you form a memory, long-term potentiation is the process that neurons begin to change and help you store that memory. So he wrote this in his autobiography, In Search of Memory. Without the mental time travel provided by memory, we would have no awareness of our personal history, no way of remembering the joys that serve as the luminous milestones of our life. We are who we are because of what we learn and what we remember. So everything that you know about yourself from this point on, everything that you believe about your personality, the things you like, the things you dislike, all of that is based on a foundation of memories that you have been forming throughout your life. When you lose those, you can potentially feel like you've lost your sense of self. And for those of you that have family members that have struggled with things like Alzheimer's disease, you can see that loss of self that potentially happens when somebody begins to lose their memories. So memory is really important. It's involved in almost every single thing that we do. So what is memory? So memory is your ability to store, to hold on to, and then later recall or remember that information. And we memory researchers have special terms for these. And by the way, this is going to be a test question, knowing the difference between the three: encoding, storage, and retrieval. So encoding is the actual process of getting information into your mind to make a memory. So encoding is the process of making a memory. Storage is holding on to that memory so that you can recall it at a later time. And then the active process of remembering is retrieval. So retrieval is when you actually consciously remember something. And I want to be careful because I said you consciously remember something. There are retrievals that you can do that are not conscious at all. Like when you get on a bike and ride it, despite the fact that you haven't gotten on it in years. That is technically an active retrieval, but you are not consciously aware that you are retrieving something. So I need to be careful and not say it's conscious. It may not be. So encoding is the act of making a memory, storage is holding onto that memory for a later time, and retrieval is the act of remembering. So why do I think memory is so important? Memory is involved in every single thing that we do. It is involved in your ability to remember to know what people around you are saying. It helps you read because you have to remember your language. You have to be able to remember what those words mean. When you travel somewhere or you go from building to building, you need to remember physical locations in space. For you to talk to people, you need to people that you know, you have to remember who they are. So memory is involved in every single thing, both conscious and unconscious. The fact that you are writing right now is actually an act of memory, even if you're not going, oh, I remember how to write. You demonstrate that you remember it because you do it. But also, memory determines our sense of self and our personality. Dr. G Fuel, Dr. G Fuel. Probably doesn't need it in the morning. All right, everybody good? Jules, do you need a little more time? Maraki, do you need more time? No. Okay. Genevieve? Okay, everybody's good? Awesome. Okay. So let's talk a little bit about the general properties of memory. Okay, So one of the first things that you need to know about memory is that memories have different durations. So I don't know if you're aware of this. Maybe I've mentioned it, maybe not. I'm technically a short-term memory researcher. So I look at short-term memory, and when I tell people that I look at short-term memory, they go, "Oh, you need to talk to me. I don't remember what I did yesterday." And it takes everything within me not to be the annoying, well, actually person, but actually, sorry, I have to. This is a class I'm supposed to teach you. What you did yesterday is technically in your long-term memory. Anything that happened 5 minutes ago is in your long-term memory. Anything that happened a minute ago is probably in your long-term memory. Short-term memory is basically about maybe 30 seconds max, and it's what you're consciously aware of right now. But let's talk about the distinction between sensory memory, short-term memory, and long-term memory. Now, you don't have to write this down the way that I have it. This is kind of an infographic designed to make a point. So when you're out in the world, you get a lot of different information from the environment. You get smells, you get sights, you get sounds, you get tastes, you get touches. Now, how much of that are you going to need for later? Probably not much, but some of it you will need. And as you're moving through the environment, you do actually need to take a minute to see to basically hold on to information to give your moving throughout the environment a sense of continuity. So it's some information from the environment we do need, because we need to move through our environment and we need to track changes. How many of you have liked to play with sparklers on 4th of July? So let's be clear about what a sparkler is. It's a tiny little point of light that's lit up, but you can use that tiny little point of light to trace shapes, right? And so for a very short period of time, you can actually draw things like a heart. What happens to that heart though? It fades really, really quickly. When you do that, you are actually looking at what we call your sensory memory. So this is basically very, very short memory for information in your environment. That includes visual sensory memory, auditory sensory memory, and touch-based. So we have a sensory memory for every single sense. We tend to know the most about vision, obviously, and hearing, and to a lesser extent, touch. Nobody really talks about taste or smell sensory memory that much, but sensory memory is designed for you to very briefly hold on to information in your external environment to give you a sense of continuity. So for example, if you didn't retain just a little bit of auditory information, everything that I am saying right now would sound disconnected. You need to have at least a little bit of a memory of the sounds that I just made less than a second ago so that you can understand the words that I'm saying. Does that make sense? And the same is true for vision. For you to see smooth motion, you do actually need to retain a memory of where visual information was before. Now, if you want to see your visual sensory memory in action, you can play with sparklers, or very slowly, especially in a dimmer lighting like this, if you slowly move your hand up and down, you might be able to see a very fleeting image of where your hand just was. If you do it with your fingers spread, it works even better. So are some of you kind of seeing that? Maybe? How many of you have turned off the TV back when TVs weren't flat screens and you can see a little bit of the image of what was left behind and then it fades? That's your sensory memory. So sensory memory is designed to be really short. It's less than a second, but you can hold a lot of information there. So we don't actually know how big your sensory memory actually is. We just know it's pretty large. So here's the thing. Some of the information that is in your sensory memory is going to grab your attention. Like if the fire alarm suddenly goes off, you're going to pay attention to that. If you pay attention to it, it is going to enter your short-term memory. Now, estimates on how long our short-term memory lasts is kind of up for debate, but estimates tend to range between 2 and 30 seconds maximum. And I would actually say that 30 seconds is a pretty generous estimate. Generally, what I find is that your short-term memory is basically what you are paying attention to and are conscious of right at this moment. So attention is critical for short-term memory. And here's the thing. Can you pay attention to everything? No, which means because your short-term memory depends on attention, if your attention is limited, your short-term memory must also be limited. So short-term memory has a short duration, certainly not as short as sensory memory, but it's pretty short, but it also has a very small capacity. We'll talk about what that capacity is later, but because short-term memory relies on attention and our attention is limited, our short-term memory is also going to be limited. There are only so many things that we can hold on to at one time. And then finally, some of the information that you get in short-term memory, you're going to need to remember for later, like some of the stuff we're talking about right now. And so you're going to try to repeat that to yourself, or you're going to try to tie that in with information that you already know, and you're going to put it in long-term memory. But wait a minute, I didn't put a duration on it, did I? Why do you think I did that? Do we know what the duration of long-term memory is? No, it could be a few minutes, but it could be an entire lifetime. You'll also notice I didn't put a capacity limit on it. We don't know how big our long-term memory can get. We're going to assume that it has infinite storage ability. Now, I don't actually know if that's true, but at least for right now, we're going to assume that it has an unlimited capacity. But remember that the more long-term memories you build, the more information you have to sort through. That's sometimes why remembering algebra when you're like 50 is kind of hard, because you have a lot of different things to sort through. That's why Are You Smarter Than a Fifth Grader always made me mad. The fifth grader has less memories to work from. Of course, the fifth grader is going to win. Adults haven't had to think about some of that stuff in years and have more memories to sort through. Okay, so what I basically showed you is a pretty classic theoretical model for understanding the different components of memory. This is what is referred to as the multi-store model. This was developed by Atkinson and Schifrin back in 1968. So here's the basic idea behind these. So we have our sensory memory. You can either pay attention to this information, or it eventually decays like sparklers and is lost forever. If you pay attention to information, it gets access to short-term memory. Now, short-term memory can only hold so many items. So information can potentially be lost here if you're putting a new item in short-term memory, but you're already at your capacity. So what happens is that something has to get kicked out. This is what is referred to as displacement, and at that point, it will be lost forever. So this original conception of short-term memory, it is a temporary place for information. Information either needs to be sent to long-term memory or it's going to be lost forever. So short-term memory, information gets kicked out if you're at your capacity. If you repeat this information because you need it for later, then it will go to long-term memory. Now, most researchers believe that once something is in your long-term memory, it's never really gone. It's never really gone. Sometimes memories that you haven't thought of in years can be brought back in the weirdest way. But what we do know is that information in long-term memory competes with each other. This is what is known as interference. How many of you have had this happen? You get a brand new PIN for your debit card. You get a brand new PIN. Note that I said PIN, not PIN number. That's redundant. That's what the N stands for in PIN. But you get a new PIN, you go to the grocery store, use the little checkout point of sale system, and you enter in your old number. How many of you have done that? That is interference. Old information is interfering with your ability to remember this new information. So nothing is ever really lost in long-term memory. It is just temporarily inaccessible. All right. So let's talk just a little bit more about these different types of memory stores. So the first one that we are going to talk about with sensory memory is visual sensory memory, which is what we sometimes refer to as iconic memory. So an icon is something visual. So this is a momentary sensory memory of visual stimuli. And as I mentioned, it's a very short duration. If you had to put a number on it, it's about 300 milliseconds. So that's about 1/3 of a second or less. So your visual sensory memory is about 300 milliseconds or less in duration. So how do we know this? So I make the cognitive students do this, but I won't make you do this. I already put you through an experiment. I'm not putting you through another one that's even worse. But we know about the duration and the capacity of our iconic memory through a pretty famous study by George Sperling back in 1960. So the idea behind this study is that I'm going to show you a grid of letters on the screen. And basically, they're only going to pop up for about 250 milliseconds. So they flash on there for a second. And Sperling had people do one of two things. First, they had to do what was called whole report. So he'd flash this grid of letters, and then people were to report as many as they could from any row. And when people do this, they tend to recall about 4 or 5 items from the entire grid. But then he did something kind of interesting. The next procedure that he did was something called partial report. So this is a little bit trickier. So he would very briefly flash the grid on the screen, and then under certain, you don't need to write this down. This is just showing you kind of how this worked. You don't need to write this part down. I've already kind of explained it. So here the letters are displayed for about 1/20th of a second. The screen goes blank. Now in a partial report procedure, here's what was different. So they got the items on the grid, and then the grid disappeared. And then they were told through a tone to either recall from the top row, the middle row, or the bottom row. So here's what's really important. They've already seen the grid, right? And the grid has already disappeared. So that here was the grid, it disappeared, and now we're telling them which row to recall. They didn't know what row they were going to get ahead of time. But here's what's really interesting. Even though participants didn't know what row they were going to get ahead of time, if the tone to cue the row was presented quickly enough, they could recall the entire row. Now, what does it mean? What does it mean? So they didn't know what they were going to get ahead of time, but once they're told which row to recall, they can recall it. What does that mean? Anybody have any thoughts on what that might mean? So they don't know what they're going to get ahead of time, but once they're told to recall it, they can recall the entire row. It means, and I know that this is kind of hard to wrap your mind around, if you don't know what you're going to get ahead of time, but you can recall all of the row, that means that at some point you must have had the entire grid in your memory. Because that could have been any row. You don't know what you're going to get, but you can recall it, which means that for a very short period of time, that entire grid was in your memory. That's wild, isn't it? Okay, so Sperling basically took this as evidence that sensory memory has a very short duration, but a very large capacity. All of the array was available for a very short period of time, but he did find that if you cued people to remember the row after a third of a second, they weren't very good at it. So what this tells us is that sensory memory has a really short duration, maybe no more than about 300 milliseconds tops. You don't have to understand the logic of the Sperling experiment. You just have to know that your visual sensory memory is very large and very short. Well, I hope you're enjoying the weather today. It's basically going to be like this for like the next week or so. It actually feels like fall. It is kind of nice to wear sweaters. Okay, so echoic memory, which is another type of sensory memory, is our auditory memory. So this is just a momentary sensory memory of auditory stimuli. So maybe you've had this experience where you're talking with your friend or you're not paying attention in class and your instructor catches you and they go, repeat back everything I just said. And you're able to do it. Like, what was I just talking about? Are you listening to me? And you're like, oh yeah, you said this thing about pickles or something like that. So that kind of shows that sensory memory for auditory stimuli also exists. Now, the length of time, like the duration of auditory sensory memory, is a little bit longer. It's about 2 seconds because speech takes a little bit longer for us to produce. Now, I'm going to be a little bit of a dork here. When I first learned about iconic and echoic memory, and I was like, this is what allows us to understand language, blah, 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 blah. I remember, so I was in my senior year of high school. This is really what made me decide to be a psychology major, was learning about these. And I remember sitting in my car with my stepfather and my sister going out to like lunch or dinner or something and being like, but echoic memory is like this, blah, blah, blah. And they were just both so bored. But I was just so happy. And this is how I became a psychology major. This is how I made the decision to become a psychology major. If I hadn't done this, I would have gone into engineering. I think I'm a better psychologist than I would have been an engineer, but I don't know. Okay, so let's talk a little bit about short-term memory. So short-term memory briefly holds a small number of items in mind for a very short time. Now, depending on who you talk to, originally back in 1956, George Miller said that the capacity of short-term memory was about 7 items, give or take. You've probably heard somebody say that short-term memory is limited to about 7 items with a range between 5 and 9. Miller's paper was called The Magical Number 7 plus or minus 2. That was the capacity limit for short-term memory. However, when you prevent strategies, that limit actually tends to be a little bit smaller than you think. Can somebody here help me? Does anybody here really like Disney? Who really? Okay, Chelsea, I have a question for you, and I'd like you to demonstrate this. If you can you please name all of the dwarves in the 7 dwarves in Snow White, please? Try your best. Do your best.
That's the one you picked. Okay. I know Doc, that's an easy one.
Okay.
Maybe Moby. I don't know.
Okay, does anybody want to help? Okay, okay. Chloe, you want to try? Okay. Okay, so both of you, I noticed something kind of interesting. So note, and odds are pretty good. If I asked this to the rest of you, we would find the same result. So this was something that Donald Broadbent actually did back in 1975. He had people recall lists of 7 items that they can remember really well, like the continents of the Earth, we have 7, or the colors in the rainbow, we have 7. And he found that even for things that people know really well, they tend to take a pause between the 3rd and the 4th item. So Chelsea, you paused after 3. Chloe paused after 5. So here's what's kind of interesting. The idea behind this is that if you have 7 items in short-term memory, you shouldn't be taking that pause. They should all be there. But the fact that we pause indicates that we're trying to remember the items, that they're not in our short-term memory. When you prevent strategies and when you prevent retrieval from long-term memory, guess how big your short-term memory actually is? It's 4. So there's how we tend to think about short-term memory now is that our capacity limit is actually closer to 4. When you don't have strategies to help you, when you don't have long-term memory to help you, it's closer to 4. And short-term memory tends to last about 30 seconds or less. Have a wonderful weekend. You have no quiz. No, you do not have a quiz. Enjoy it. But I did set up practice quizzes for chapters 5, 6, and 7 if you would like to practice and prepare for your exam on Wednesday. So I will see you Monday. We will pick a time for our review session on Tuesday. I will see you later. Have a good weekend. No, you're not.